So now we will graph a quadratic function on a restricted domain. A quadratic function has the input squared, x squared, with no higher powers of the input. So there's no x cubed, no x to the fourth, etc. But it could have x to the first also, because that's a lower power, but the highest power is x squared. When you graph a quadratic function, you get what's called a parabola. And a parabola is a curve that either opens downward like this or opens upward like this. Okay? So that's what we're looking at here. Quadratic has x squared, and its graph is going to be one of these two things. And we'll graph these here so we can focus on what we have. We'll graph these by plotting points as opposed to using any more technical techniques for graphing parabolas. We'll jump right into graphing this parabola on the restricted domain where x is between -4 and 4. Since our restricted domain is -4 to 4, we look at those x values, which is going to be from -4 to 2, so -4 to +2. This is the region in which our graph is going to take place. No other x values are part of this function. So that's what we'll consider here. And we'll do this by plotting points. So let's look at the ends of this first. So if x equals -4, then in this case y is going to be 16, -4 squared, plus -8 minus 4. Well, 16 minus 8 is 8, and 8 minus 4 is 4. Okay? So if x is -4, we get +4. So -1, 2, 3, 4. And y is +4, so +1, 2, 3, 4. And this point is included because x can equal -4. Let's look at the other end of this graph at +2. So if x equals +2, y is going to be 2 squared, which is 4, plus 2 times 2, which is also 4, minus 4. So that's 8 minus 4, which is 4. So coincidentally, if x is 2, y is also 4, so that's up here. However, we use an open circle here because x has to be less than 2. It can't equal 2. So our graph is going to stop at this point, but it doesn't include that point. So we have to leave it as an open circle. Now let's fill in between. I don't know, we could just use all the integers here, like -3, -2, -1, 0, and 1. So if x is -3, we get 9 minus 6, that's 3. 3 minus 4 is -1. So if x is -3, y is -1. X is -2, we get 4. Minus 4, that's 0. Minus 4, that's -4. So if x is -2, we get -1, 2, 3, 4. If x is -1, we get +1, minus 2, that's -1, minus 4 is -5. So if x is -1, we're -5. We can start to see that this graph is curving, right? If x is 0, we get 0 plus 0 minus 4, that's -4. And so now we have this symmetry. Parabolas are always symmetric, so the next point, if x is +1, we should get y to be the same as this, right? Which is -1. So let's see. If x is 1, we get 1 plus 2, which is 3. 3 minus 4 is -1. And so we get it. And now we could just connect the dots here. So this is our restricted domain parabola. We've cut off the ends of it, right? And we've got our open and closed circles on the ends appropriately, depending on whether or not the two endpoints, -4 and 2, are included.